Okay, this system is basically based on a auger which consists of spiral flights and paddles to stir and move material through this reactor chamber over here. The auger operates in an open trough where the reactor chamber, which we're looking at the moment, is preheated with, in this instance, LPG gas, propane gas, to around about 400 to 500 degrees centigrade. We introduce the organic biomass. The biomass, once it hits the hot atmosphere inside the reactor chamber, at first it pre-dries, dries down, then it starts to torrefy and then pyrolyze. When it torrefies and pyrolyzes, it releases gas, syngas we call it. This syngas then ignites, and then the system is self-sustaining. The syngas provides the energy for the system to operate, and it's self-sustaining through the continuous process of introducing new material, and that material pyrolyzes and releases the gas to run the operation. The gas exits through the exhaust system at the top, which is the large square apparatus in front of us. The system is maintained with air that is introduced in 3 different locations. The air is not introduced to the biomass itself. If you do that, you have gasification, combustion. What we do is introduce the air around and above the biomass to mix with the syngas that is being produced in the pyrolysis and torrefaction process. Then we have a fuel-air mixture which ignites the combustion gases that are generated above the biomass, then radiate heat back down on the system or the biomass. The combustion gases that are generated above the biomass then radiate heat back down on the system or the biomass, and keeps the system basically operating perpetually, really. If we go around to the back end of the machine, you'll see the stainless steel auger, which is taking material from the exit end of the reactor chamber, the exit end of the trough and paddle system. So material has been moved slowly through the system, then up, out through this auger. In this auger, water is introduced, or any other liquid medium. We experiment with a lot of different liquids to value add the char, because as the char is exiting the machine, it is generally in the region of 500 degrees centigrade. So you can't expose that directly to the atmosphere, otherwise it will oxidize, combust. So we introduce water in this particular auger, and that cools, quenches the biochar so that there's around about 20-25% moisture, which also keeps the dust level from the char to a very, very low level. You have to be aware that you do not want operators to be breathing the dust. So this is a very clean operation in terms of being user friendly. You don't want to hurt anybody or cause long-term effects. The second auger just basically takes the material up to the bagging frame here, where we just load it straight into bulk, what we call bulk bags here. I don't know what they're called elsewhere, but just polywoven bulk bags. And the material that comes out just basically drops in here, and this is the material that we get from poultry litter. This is basically the bedding and the poultry manure that comes from broiler sheds, chicken sheds here, and as you can see, it just becomes a very friable black uniform material. One of the best biochars you can actually make for what we do, and that's why we specialise in this particular instance in pyrolysing poultry litter. Very high in nitrogen, phosphorus, potassium, calcium, sulfur. It's a broad spectrum fertilizer in its own right, and when you think that the carbon that I've got in my hand here stays in the soil not for hundreds of years but thousands of years. So what you're seeing is atmospheric carbon converted into organic carbon for the soil that makes soil work better, more sustainably, not just for our generation but for generations and generations to come.